Hello बच्चों, let's read the question. So the question says two particles of mass 0.5 kg and 0.25 kg moving with velocities 4.0 meter per second and minus 3.0 meter per second collide head on in a perfectly inelastic collision. Find A. The velocity of the composite particle after the collision. B. The kinetic energy lost in the collision. So let us first understand the question. So we have a particle, let's suppose particle 1, its mass is 0.5 kg and it is moving with velocities 4 meter per second in this direction. Let's suppose there is a particle 2 with mass 0.25 kg. It is moving with velocity minus 3 meter per second, which means that if we take positive direction here, so it will be moving in this direction with 3 meter per second. Okay, so now what we have to find? We have to find the velocity of the composite particle. After some time, they collide and become one composite particle which moves with velocity v, let's suppose, and its mass will be 0.5 plus 0.25 equal to 0.75 kgs. Okay, now we have to find this velocity, and in B part we have to find kinetic energy lost. So we have to find kinetic initial energy minus final kinetic energy. Okay, so it is the kinetic energy lost. Now let us jump right into our question. So solution part, what do we have? We have we can apply. Let's revise the key concept first. So the key concepts behind this question are: first, as there is no external force acting on the particles, we can apply conservation of linear momentum. Okay, we can apply conservation of linear momentum. And second is the loss in kinetic energy. Loss in kinetic energy will be equal to initial kinetic energy minus final kinetic energy. So now apply conservation of linear momentum. So for solution part, what do we have? We have applying conservation of linear momentum. So initial linear momentum of the two particles will be equal to m1 u1 plus m2 u2, and it must be equal to final kinetic linear momentum, which will be equal to m1 plus m2 times v. Okay, because the velocity of composite particle is assumed to be capital V. Now let us put the values. So we have 0.5 into u1 is 4 plus 0.25 into u2 is minus 3 is equal to 0.75 times v. So from here, solving this, we get 2 minus 0.75 is equal to 0.75 times v. So from here we can calculate v is equal to 1.66 meters per second. Now it has come to be positive, so the particle will be moving in this direction. Now for the second B part, this was A part. Now for B part, what do we have? We have to calculate kinetic energy lost. So it will be equal to half m1 u1 square plus half m2 u2 square minus half m1 plus m2 times v square. This is the initial kinetic energy, and this is the final kinetic energy. And we have seen in our key concept that the loss in kinetic energy will be given by Ki minus Kf. So we have initial kinetic energy minus final kinetic energy as our answer. So it will be equal to half of m1 u1 square plus half of m2 u2 square minus half of m1 plus m2 times v square. So it will be equal to half of 0.5 times 4 square plus half of 0.25 times minus 3 whole square minus half of 0.75 times 1.66 square. So solving it, we get half of 8 plus half of 2.25 minus half of 2.083. Now on solving this, we get it equal to 4.083 joules. So this is the loss in kinetic energy. This is our final answer. I hope you understood it well. Thank you.